Okay, so I got it recorded, and give you a little backdrop. So I remember, when online education first came out, late 1900s, early 2000s, University of Phoenix was kind of big into it, and everybody thought, oh, that's just a fake degree, and that doesn't count for anything, and nobody's going to want to do that. You guys are really on the cusp of it's been an accelerating momentum anyway. I've been doing it most of my education, except for the calculus stuff, primarily online since about 2014. But it is the wave of the future. We're in the midst of dealing with a global pandemic, and the reality is it's not going to change. It's going to continue to be more and more this way. So when I was trying to do a little workout with my wife this morning, she has ones that she likes, and it's a couple that they're doing some aerobic things. So I was doing that with them, and they're talking about, hey, the body that you have is the only one you got, so you got to treat it right. Well, I don't always do that, right? So, but in reality, that makes a lot of sense. So we got to make smart decisions day in, day out, whether it's eating meals or getting your exercise in or doing those types of things. But also the brain you have is the only one that you have. And the other thing that I want you guys all to realize is that going through this process where more gets put on you as the student, understand that I'm on your side, right? I want you to excel. I want you to understand stuff. I don't want anybody to go through this process and feel lost or like they don't understand. So make sure that I understand this is a college level course too, but still as a college professor, I want to help my students excel and be the best that you can possibly be and develop the only brain that you have to carry with you no matter what you do in life. So we want to use the tools that you're learning in here to make you better at the other things that you go on and do. So make sure that you reach out to me if there's questions, concerns, things like that. And we're all going to kind of stumble through as far as how we got to do things when we go through some hiccups. But with adversity comes opportunity, and this is going to make you better for what you do next year. Similar to last spring, those students that had to be forced to online with me halfway through, they are benefiting. I've talked to a few of them. They're benefiting now at the university level because they had to do that. Anyway, let me get off my, once again, that's just a reach out, just to let you know I'm willing to help you really at any time. So you have the ability to contact me. Make sure you ask questions as you have them. What I'd like to do is I'd like to share the application screen. I think I can. So I was able to get it up on this one. So hopefully right now you can see Khan Academy. Can I get an amen on that? Or a yes?
Yeah, we can do it.
So I can't assign, I've saved assignments, but they have some nice stuff. I told you on limits, one-sided limits, limits from both sides, graphical interpretation of limits. I'd like you to do those, but I can't assign it to you until you get signed up. So that was something that I didn't realize. I thought I was just doing something wrong. So anyway, what I sent to you on WhatsApp, if you go to Khan, which is KHAN academy.org. Anyway, or whatever that link is, and then /join, and then that code, that should take you right to this class, and you should see my name as your teacher. So if everybody could do that right now. Kylie, I know you're sharing a computer. Do you happen to have yours with you?
Yeah, I already got on Khan Academy.
Okay. And hopefully, did you get on, you already did it on my course, or you're in my course where you can see my name?
Yes.
Okay. So, students, let me go to students. 8 new students. Awesome. Okay. So that's good. Looks like you're all in. Perfect. So, all right. So really not everything. There's 103 assignments. So I do want to kind of show you. I want to take you through. So we got limits and continuity. That's the first unit. So there's different things here. Some of these are just lessons or reading things. Really, we're doing that together. So you don't have to do all that stuff, but anything that has exercises, whoops, sorry, I can give a pop-up anyway. Anything that has exercises, I want you to do. And so if I click on this, it makes a new pop-up screen. So you probably can't, you probably can't see this, can you? So, or can you? Yeah, you can see my pop-up. You can see the graphs.
Yeah.
Okay, perfect. So anyway, and you just go through, and the limit as x approaches -4 of f of x. Well, as x approaches -4, I'm going to hit that height of, I don't know, looks like somewhere just a little bit above 3, right? So it looks like maybe 3.3 is a closer answer. We hit that. Apparently this is student view, so I can't do it, but if you click that answer and it's right, you're going to get stars or fireworks or something awesome that makes you feel really good. So anyway, just go through those, and all I ask is that you get 4 out of 4 when you do those. And so if you mess one or more up, just go do it again. It doesn't take long. It's real quick and easy. And if you want help with different things or some additional tools besides what I've done, you can actually do that. The squeeze theorem we have not covered, so there's going to be certain things that we have not covered yet. Continuity, so quiz 3 on, or basically squeeze theorem on down, we have not done yet. So even though you might have access to that, you can leave that for later. At the end of those, all those question things, there's a quiz as well that you can take also. So I can see how much time you spend on it. I can also see the results of what you have. So we're going to use this as just some additional quick hit learning, just to make sure that you got all that stuff correct or down in your things of that nature. Let's see. All right. So, all right. Make sure you have those concepts down. Any questions for me as far as what you've got going? I think everybody got their homework turned into me through 1.6. What I'll try and do is I will try and make sure that you have that by the first, by Tuesday at the latest, have it back, have some feedback on all the stuff that you turned in, because next Thursday is going to be that 50-point half test during homecoming week and all the chaos you're going to have there. So I just want you to know about it so that you're preparing for that as we go, because that's going to be something where you can't use your notes and you can't use your book and you can't use your friends, those types of things. And it'll be a write out deal, similar to the homework to turn in. All right, so anyway, moving on, let's finish up with 1.7 then. And I'll WhatsApp you as far as I'm going to get those assignments. Those assignments aren't ready for them, so I think I have to go back. Maybe it did it. I might have actually just done it, but I got to assign that stuff to you, and then I got to change the due dates possibly too. But anyway, I think I just put September 30th for all of Unit 1, which is, or all of that limit and continuity stuff. Obviously, not all of it's going to be due by September 30th because squeeze theorem on down is not yet. Okay, let me grab this pen. And so if there's no specific questions here, let's just go back into the whiteboard. And at this point, everything stays stable. I'm planning on being back in there with you next Thursday. So also, if not before, but Thursday for sure. All right. So hopefully you can see the whiteboard. If not, let me know. we were looking at section 1.7, and section 1.7 is infinite limits, right? And we have a couple theorems here. So we're looking at infinite limits, limits that approach infinity, plus or minus infinity. So let's look at a couple theorems, which are proven facts. First of all, if we have R is an element of the some number that's an element of the natural numbers. So the natural numbers, remember, is the set containing 1, 2, 3. It's the counting numbers, right? Etc. So if R is an element of the natural numbers, then the limit as x approaches 0 from the right of 1 over x to the R power equals positive infinity. So basically, what we're going to end up doing, if we have 1 over x squared is the one we looked at yesterday, correct? And so if we have the limit as x approaches 0 from the right of 1 over x squared, it actually approaches positive infinity. And this is going to be true no matter what, even if x is odd. So let's look at an example. If I have the limit, right-handed limit at 0, so the limit as x approaches 0 of 1 over x to the 99th power, then this is going to exist and equal positive infinity. So basically what happens is what we have, if you plug it in, if you plug in 0 for x, we're going to have 1 over a positive 0 to the 99th power. Now, what does positive 0 mean? That doesn't make sense. 0 is neither positive nor negative, right? But really what this means is a tiny number, a tiny positive number raised to the 99th power is going to be a very tiny positive number. So ultimately, this is 1 divided by a very tiny positive number. And if you have a fixed positive number divided by something that's getting closer to 0, something very small, it explodes. And so it's going to explode up to positive infinity. And then we have the second part of this theorem. Let's approach it from the left. If the second part of this, so this is 1 here. R is an element of the natural numbers. This is theorem part 1. Theorem part 2 of this for R being an element of the natural numbers. Then the limit as x approaches 0 from the left of 1 over x to the R power. Well, this is going to depend here. It's going to depend on what x is, right? Excuse me, what R is. Sorry, because it's going to be a tiny negative number. So this is going to approach negative infinity if R is odd. And it's going to approach positive infinity if R is even. Because if R is even, what happens to the minus sign? Remember, this is a tiny negative number. And if it's to an even power, a tiny negative number squared is going to square out that minus sign, right? So it's going to be, in this case, it's going to be 1 divided by a positive 0, right? Where up here, it's going to be 1 divided by a negative 0. Because the negative sign, if I have 1 over x to the 3rd power, and I have negative numbers approaching 0, then when I cube it, it's still going to be negative. And once again, the numerator is a positive 1. So we have a couple nice theorems that way. Let's continue on here. And let's just note a couple of things. So let's see some number. So there's just some positive number, right? C is some positive number. If I have that, then what does C, when you divide it by a number that approaches 0 in a positive way? Well, a positive fixed number divided by something that's getting smaller and smaller explodes up, and it's going to explode to positive infinity, right? We can also say that C divided by a number that approaches 0 in a negative way, or a tiny negative number, is also going to explode, and it's going to explode to negative infinity. Okay, so that's when C is some positive fixed number. So that number, C could be like pi, and then the denominator approaches 0. And if it approaches 0 in a positive way, it's going to, the limit would approach positive infinity. If it approaches in a negative way, it approaches negative infinity. So let's look at another scenario here too, and let's let K be some number less than 0, so some negative number, and negative real number, right? So if K is negative, then if I take K and I divide that by something that approaches 0 in a positive way, I have a negative fixed number divided by a tiny positive number that's going to explode, but it'll explode downward to negative infinity because K is negative. Negative divided by positive is negative. Similarly, if I take that negative fixed number K and divide it by something that approaches 0 from below, this is also going to explode, but it's going to end up exploding to positive infinity. And why is that? Because really it's negative divided by negative, which ends up being positive. And because I'm dividing by something that's getting smaller while K stays the same, it explodes. So when it explodes, these are limits at infinity. So hopefully all that makes sense for you, a couple theorems there. So we have a couple other theorems here. So let's look at another theorem. If let the limit as x approaches 0, or x approaches a, let's do any number. Let's not approach 0. Now let's approach any number a. A could be positive, a could be negative. It doesn't really matter. But we're approaching a from both sides. So if we let the limit as x approaches a of g of x equal c, where c is some positive fixed number, okay? So we have that. And the limit as x approaches a, the same a, of f of x approaches 0 in a positive way, then what we can say is the limit as x approaches a from both sides of g of x divided by f of x is actually, well, what's this going to equal? This is going to equal a fixed number c. It approaches c on the top. It approaches 0 in a positive way on the bottom. And since c is positive, this explodes, but it explodes to positive infinity because it's positive divided by positive. So that should make sense there. We can do some other things like that as well. And so let's look at just using these, a couple quick hitters. We did a little bit of this yesterday, but if we look at an example, let's look at the, so let's let f of x equal 2 over x to the 10th power. Then the limit as x approaches 0 from both sides, okay, of 2 over x squared, or x to the 10th, is going to end up being, we could say the limit of the quotient is the quotient of the limit, right? So LQ equals QL if we wanted to label that. So that'd be the limit as x approaches 0 on top of 2 divided by the limit as x approaches 0 from both sides of x to the 10th. And then, of course, we can say the top one, the limit of a constant is a constant, right? So that's going to be 2 on top. And then on bottom, we have the limit of the exponent is the exponent of the limit. So it's going to be 0 to the 10th power, right? Which ends up being a positive 0. So remember, 0 can be approaching from the right. So it's a positive 0 to the 10th, which is a positive 0, or it could be a negative 0. We could be approaching 0 from the left, which would be a negative 0, quantity to the 10th power, but that'll square out all the negative signs. So we have a positive 2 divided by a positive 0, which ends up being, or something that approaches 0 in a positive way. So once again, that goes back to that theorem that we had. That's going to end up being positive infinity. Now, what I'm going to do is I'll show you what I'll do. Instead of writing all this out, we've already been through this, right? So instead of writing all this out, which is showing the details, what I can do is say, hey, this because limit of the quotient is the limit. What is that? Whoops, 2 divided by a positive 0. We're just going to go ahead and plug those in and say that that equals positive infinity. So I'll let you, by the way, if you just write infinity, it's positive. So you don't have to write the plus. All right. Everybody good on that? So I got no questions. Pretty basic stuff, isn't it? Hopefully. All right. Once again, this is just the same thing we were doing before. It just happens to be infinite limits. Let's look at another example. If I have the limit as x approaches 5, and let's go from the right of 1 over x minus 5. Now, this is a little bit different than the one we had yesterday, right? So if I plug in here, I could say limit of the quotient is the quotient of the limit, and then you plug in as a polynomial. But if I do that, I'm going to get 1 on top because the limit of a constant is a constant. On the bottom, if I plug in 5 for x, I end up getting 0. But what we have to do is we have to determine what kind of 0 do we get. Okay? In this case, I'm approaching 5 from the right. So that would be like 5.1, 5.01, 5.001. Subtract 5, I get a smaller and smaller and smaller number, but it's actually going to be a positive number, right? So I'm approaching 0 in a positive way. So hopefully that makes sense to you. Anyway, now I have a positive fixed number divided by something that's approaching 0 in a positive way. That approaches positive infinity. Let's look at approaching from the other side. Let's take the left-handed limit. So if I take the limit as x approaches 5 from below, of 1 over x minus 5. Well, this is the same thing. Limit of the quotient is quotient of the limit. Limit of the constant on top. Limit of, as x approaches 5 from below, 1 approaches 1, right? But if I plug in 5 here for x, because that's a polynomial, I end up getting 0. However, we don't touch 5, we just approach it. The question is, what kind of 0, or how am I approaching 0? So I never hit 0. I'm actually hitting tiny numbers. But as I approach 5 from the left, that would be like 4.9. Use an easy example. Well, that would be negative 1/10. And 1 divided by negative 1/10 would be negative 10. If I said 4.99 and plug that in, that's negative 1/100th, which to that would be negative 1. 1 divided by negative 1/100th is negative 100. And we'll get closer to 0 on the bottom in a negative way, which makes the whole thing blow up. So basically, if I had negative 1/100 on the bottom, the quotient would equal negative 100. But anyway, this is going to explode to negative infinity because it's a positive number on top divided by something that's getting closer to 0 in a negative way. So we do have to look at that. And then last but not least, then we could say, hey, what's the limit as x approaches 5 from both sides? So realize that I could end up doing this to you on a quiz or a test. So the problem could just be what I'm putting in purple here. The limit as x approaches 5 of 1 over x minus 5. And you might say, hey, that's 1 over 0, which blows up. Right, but which way blow up? The reality is this does not exist, right? And the reason for that is the right-handed limit and the left-handed limit, as I approach 5, while they both exist, they do not equal. And very quickly, we could graph this. X equals 5 is a vertical asymptote, and what this ends up being is a right shift of 1 over x. So basically, I'm approaching positive infinity from the right and approaching negative infinity from the left. And of course, I could have my y-intercept here of minus 1/5 there. And this is over, this vertical asymptote here is at x equals 5. So similar to the one we had yesterday, except that was on the left side. I think I had x plus 5 in the denominator. But hopefully that makes sense. Remember, if we want the limit to exist, it's got to be the same on both sides, not different. All right, so let's look at a couple of more complicated examples before I run out of time. I got about 10 minutes left. I'll set my alarm here for 2 o'clock. Should be easy adjustment because I set it for 1. Make sure you get out. By the way, if the bell rings, you're allowed to leave my course. I'll start seeing people leave if I'm still talking. I'll keep it recorded, but you're allowed to leave if the bell went off and I'm talking. All right, if I'm not there. All right, let's look at real quick. So, oh, by the way, what's let me define something first. So definition here. Definition, what is a vertical asymptote? Some people call that asymptote. I call it a vertical asymptote. Okay, so a vertical asymptote occurs at x equals a if and only if one of the following happens. First thing, bullet point 1, the limit as x approaches from the right of f of x, a vertical asymptote, I should say for f of x, occurs at x equals a if and only if the right-handed limit equals plus or minus infinity, or the second thing that could happen, the left-handed limit as you approach a, the limit as x approaches a from the left of f of x equals plus or minus infinity. So really there's four outcomes here, right? 4 possible things that could cause a vertical asymptote. One is the right or left-handed limit is positive infinity, that's 2 of them, or the right or left-handed limit is negative infinity, that's 2 of them. And we don't care what it is on the on both sides, we just care that one of them explodes upwards. Okay, that's going to end up getting a positive or a vertical asymptote. Okay, so that's one of the definitions of vertical asymptotes. The let's look at a couple examples now where we have some awkward stuff. So back to what I did on the sideboard, kind of early aim of calculus. Let's look at the limit as x. This is number 17, by the way. Hopefully some of you worked on these. But anyway, this is important not only to work odd exercises similar to what you turn in, but do some other ones. And make sure you get the answers in the back of the book. And if you're not getting the answers in the back of the book for the odd exercises, and you're not sure why you didn't get that right answer, that's when you need to reach out either to a buddy or to me or on WhatsApp or whatever. Any odds I'm willing to do in excruciating detail. If I can't get it, then you don't need to worry about it. I've got stumped a couple of times, but I usually end up figuring them out at some point. But anyway, if I do this, I can say limit of the quotient is the quotient of the limit, right? So we could do all that. Limit of the quotient is quotient of the limit. Then on top, limit of the root is the root of the limit. And then we have a polynomial, right? For both of them once we get to that point. So ultimately, I can just plug in. And so on top, if I plug in, I'm going to get 3 plus what kind of 0? It's going to be 3 plus something that approaches 0 in a positive way, which really doesn't matter how it approaches 0. And then on the bottom, I'm as x approaches 0 from the left, what does this one approach? It approaches 0 from the left. So really what we have here is the numerator, we have the square root of 3. Well, we should know the square root of 3 is 1.732, blah, 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 right? So I only know it to the nearest thousandth. But anyway, divided by, that is a fixed number, right? Divided by, whoops, what kind of 0? A negative 0, right? So it's going to be a positive fixed number divided by something that's getting closer to 0 in a negative way, so it will explode, and this ends up going to negative infinity because it's a positive fixed number divided by something that's approaching 0 in a negative way. Positive divided by negative is negative, so it explodes to negative infinity. Hopefully that makes sense. Okay, so, you know, the back of the book may not show the work on this. So you gotta, you know, make sure you're showing the work on your stuff. Let's look at number 19. We're using red to fire you up, I guess, on a Kemper Friday. So we've got on 19, we've got the limit as x approaches 3 from the right of the square root of x squared minus 4 all over x minus 3. I believe this is right. Well, in this case, if I plug in 3, because I do the quotients, quotient limit, etc., I get some kind of 0 over 0. Now, the question might be in your head, do I have to worry about what kind of 0, if it's a positive or negative 0? No, I don't have to worry about that yet, because we know that this is an indeterminate thing there. So what I need to do then is I need to manipulate this in some way. I'm sorry, this is, it's not 0 over 0 if I plug in 3. It's the square root of 5. So this, I can't read my assistant's writing. Anyway, it's x squared minus 9, square root of x squared minus 9. Then if you plug it in, it's 0 over 0. The way I had it, it would have been the square root of 5 divided by, then we could look at what kind of 0, divided by a positive 0, which would have been positive infinity. But in this case, now I get 0 over 0, because I get the square root of 0 divided by 0. So we need to manipulate this. So there's one of two ways we can do this. I could end up factoring this. And so I'm not going to take the limit yet, but the limit as x approaches 3 from the right of the square root of x plus 3 times x minus 3 under the radical, and then I'm going to split that out. Square root of a times square root of b is the square root of a times the square root of b all over x minus 3. So that's one way to do it. And then what I could do is I could cancel these out. So there's a couple different ways to do this, but if I have the square root of a over a, what does that equal? That's equivalent to 1 over the square root of a, right? Because I could rewrite the bottom one as square root of a times the square root of a, and then one of these cancels out, and it cancels to 1 on top and the square root of a on the bottom. So I could cancel this out and just have the square root of x minus 3 on the bottom. Okay, so that's one way to think about this and do it. The other way is to rationalize the numerator. So we'll look at that. But anyway, let's go ahead and do this now. Now, if I plug in 3 from the right, on the top, I'm going to get the square root of 6, right? And once again, I don't care if it's approaching 6 from the right side, because it is, or from the top. It is, but that doesn't matter. 6 is a positive number. The square root of 6 is a positive fixed number, right? Divided by, on the bottom, when I plug this in, now it matters, because I'm going to have square root of some type of 0. And in this case, that 0 has to be positive, otherwise the limit doesn't exist. So we have to note that if I had 3 from the left, the limit as x approaches 3 from the left, I'd be getting a negative 0 there, and I cannot take the square root of a negative number, no matter how small it is. The limit from the left would not exist. But anyway, by doing it this way, I'm going to get the square root of 6 over square root of a positive 0 is a positive 0. So a positive fixed number divided by something very small explodes to positive infinity. So that's the correct answer there. Now, there is another way to do this same. Don't have a lot of room left, so let me just do number 19 again. If I had, so I had the limit as x approaches 3 from the right, x squared minus 9 over x minus 3. If somebody might say, well, couldn't you just multiply top and bottom by the square root of x squared minus 9? Well, I could, and if I did that, that's okay to do. It'd be, remember, I don't actually hit 3, I just approach it. This would be approaching in a positive way, so that'd be fine. And if I do that, this is going to be equivalent to the limit as x approaches 3 from the right of square root of a times the square root of a is a, right? So that just becomes x squared minus 9 over, on the bottom I would put factored, x minus 3 times the square root of x squared minus 9. And if I do that, what I can do then is I can now factor the top as the difference of two squares. That's x plus 3 times x minus 3. And then realize that, hey, the x minus 3 and the x minus 3 goes away because that, that's what makes it 0 over 0. Still would be 0 over 0. But now, if I do this and then plug in, I'm going to get, plugging in now, I'm going to get 6, which is actually a positive 6, divided by the square root of a positive 0, which ends up being positive 0. Once again, same answer, which we would expect. There's only one correct answer, and that's positive infinity. Number 21, I want you to try that as well. You can factor that or try and get a combined like terms or things like that. You can manipulate, but long story, remember there's some indeterminate forms on my 1 minute warning. So infinity plus infinity, well, that's infinity, right? And minus infinity is minus infinity. So you keep going left. But if you have infinity plus infinity, or not plus, if you have infinity minus infinity, this is indeterminate. We don't know what this is because you don't know which infinity is bigger. So on number 21, I'm just going to show you that real quick. We have limit as x approaches 0 from the right of 1 over x minus 1 over x squared. Both of these end up being infinity, positive infinity minus positive infinity, but we have to manipulate this, and what we really want to do is write that as x minus 1 over x squared to figure out which infinity wins, and then take the limit. So I'll let you do that. There's only one correct answer here because you don't know what infinity minus infinity is. Okay, so I think I'm out of time. If you got any questions, reach out to me individually. Happy Friday, and be safe over the weekend. Good decisions. I'll see you Monday, and I'll send out on Con.